High above the frozen North Pole of Saturn, there is a giant, glowing star hiding in the sky, and it is missing two of its 6 points, like someone reached up and erased them. Scientists expected to find nothing up there but a faint, boring haze. Instead, they found a shape that should not exist on any planet we have ever studied. Stick around because this story gets stranger the deeper we go. Before we dive in, tap subscribe if you want the next big space mystery to land in your feed the moment it breaks, because this one is still unfolding right now. What we are about to describe was not spotted by some far-off telescope pointed at another galaxy. It was found right here in our own solar system, on a planet you have probably seen 100 pictures of. And yet nobody, not one scientist on the team, expected what they saw. Picture this. A telescope powerful enough to read a firefly from the distance of the moon turns its eye towards Saturn. It is not looking at the famous rings. It is looking higher, into a thin, ghostly layer of gas above the clouds, a place so faint that almost no one has ever managed to study it properly. And in that thin layer, the telescope finds a chain of dark beads, floating like a string of black pearls drifting slowly around the planet. Below those beads, in a deeper layer of gas, there is that broken star we just mentioned, glowing faintly, lopsided, wrong. Nothing in the textbooks predicted either of these things. Nothing in 50 years of studying Saturn prepared scientists for a beaded necklace of darkness and a crooked star sitting on top of one of the most photographed planets in the sky. By the end of this video, you will understand exactly what these shapes are, why they terrified the very scientists who found them, and why nobody can yet explain what is really going on above Saturn's clouds. Now let us start from the beginning, because to understand why this discovery shook people, you first need to unlearn something you probably believe about Saturn. Most people think Saturn is a simple, quiet planet, a big ball of gas with some pretty rings wrapped around it, calm and predictable. That idea is wrong. Saturn's upper atmosphere is actually one of the most mysterious, least understood places in our entire solar system, and scientists have been trying to peek into it properly for decades. Here is why it is so hard to study. The layer we are talking about sits far above Saturn's clouds, so high up that the gas there is incredibly thin and gives off only the faintest possible glow. Telescopes on Earth, even the best ones, struggle to catch that glow at all. It is a little like trying to see the light of a single birthday candle from across a football stadium, on a foggy night, through a dirty window. For a long time, that faint candle simply stayed hidden. That changed with a spacecraft called the James Webb Space Telescope, or JWST for short. JWST does not orbit Saturn. It sits far away, out past the orbit of the Moon, at a special parking spot in space, about 1 million miles from Earth. From there, it uses a giant gold-coated mirror, more than 20 feet across, to gather infrared light, the kind of light our eyes cannot see, but that carries heat information from distant objects. In the year 2025, astronomers finally pointed this powerful eye directly at the top of Saturn's atmosphere, right above its famous six-sided storm at the North Pole, and they got a look nobody had ever gotten before. Before JWST, our best information about Saturn's upper atmosphere came from a spacecraft called Cassini, run by NASA and the European Space Agency, which orbited Saturn for 13 years, from 2004 until 2017. Cassini flew closer to Saturn than any spacecraft before it, and it taught us an enormous amount. But even Cassini could not clearly see this thin, faint upper layer of gas. It was simply too weak, too easy to miss, hiding in the glare of everything else happening around the planet. So, when JWST turned its infrared eye toward that exact same region in 2025, it was not just adding a little more detail to an old picture, it was seeing an entirely new picture for the very first time. And what came back was not what anyone on the science team expected. Let's talk about what they actually found, one discovery at a time, because the deeper you go, the stranger this story gets. The first surprise came from a layer of gas scientists call the ionosphere, which sits about 1,100 kilometers, or roughly 680 miles, above Saturn's cloud tops. That is nearly 3 times higher than the cruising altitude of an airplane on Earth, if that airplane could somehow keep flying straight up into space. In this layer, gas particles get charged with electricity from the sun and from Saturn's own magnetic field, kind of like the way a balloon gets a static charge when you rub it on your hair. Scientists expected to see a smooth, even glow across this layer, similar to what they had modeled using older, weaker observations. What they actually found was a chain of dark patches, spaced out unevenly, sitting between 55 and 65 degrees north latitude, which on Earth would be roughly the latitude of southern Alaska or northern Scotland. The team nicknamed them dark beads, because in the images they genuinely look like a string of dark pearls laid across a glowing background, each one separated from the others by enormous gaps. To put the size of this in perspective, remember that Saturn's whole atmosphere is already almost 10 times wider than Earth, so a chain of dark beads stretching partway around Saturn's pole is not some tiny local weather pattern. It is a structure that could swallow entire continents, floating quietly above a planet 900 million miles from the Sun, 10 times farther from the Sun than Earth is. And yet, up close, in the data, it looked almost as delicate and ordinary as beads left lying on a kitchen counter. The second finding changed everything, because it came from a completely different layer of Saturn's atmosphere, sitting about 500 kilometers, or just over 300 miles, below the dark beads. This layer is called the stratosphere, and it is where a gas called methane, the same gas that gives Saturn part of its blue-green tint in certain wavelengths, glows faintly under infrared light. Scientists expected this deeper layer to be calmer, since it usually behaves more predictably than the electrically charged layer above it. Instead, they found a star-shaped pattern glowing in the stratosphere, stretching outward from the pole almost toward the equator. A normal, healthy version of this kind of pattern, if it followed the physics scientists expected, would have 6 even arms, spaced neatly around the pole like the numbers on a clock. What they actually saw had only 4 visible arms. 2 of the expected 6 were simply missing, leaving a lopsided, broken-looking star hanging above one of the most iconic planets in the sky. Compress that for a second. Imagine drawing a 6-pointed star on a piece of paper, then erasing 2 of the points, but only on one side, so the whole shape leans awkwardly to one direction. That is roughly what scientists were staring at, except this star was made of glowing gas, spanning distances wider than our entire planet, floating silently above Saturn's North Pole. Professor Tom Stallard of Northumbria University in the United Kingdom, who led the research team, later said the results came as a complete surprise, and that at the time they were found, the features were completely unexplained. It helps to remember that Saturn itself was underestimated for a very long time. For centuries, people thought of it as a pretty but simple decoration in the night sky, famous mainly for its rings, rarely taken as seriously as Jupiter when it came to studying wild, chaotic weather. Jupiter got the reputation as the dramatic gas giant, with its giant red storm bigger than Earth. Saturn was treated almost like the quiet, less exciting sibling. This discovery flips that story completely upside down. So here is a question for you before we keep going. What is the strangest thing you have ever learned about a planet you thought you already understood? Drop it in the comments below, because reading what surprises you most helps me understand exactly which topics to dig into next. Let's keep building this picture, because the beads and the star are only the beginning. Once the science team confirmed both shapes were real and not some kind of camera glitch, they had a new problem on their hands. They needed to figure out whether these 2 strange features, sitting in 2 different layers of gas, were somehow talking to each other. Here is the exact kind of detail that makes this story feel like real detective work. The team tracked Saturn's atmosphere for just over 10 hours straight, watching the dark beads and the broken star as the planet rotated slowly beneath the telescope's gaze. 10 hours might not sound long, but for context, that is almost exactly 1 full rotation of Saturn itself, since a single Saturn day lasts about 10 hours and 33 minutes, less than half the length of a day here on Earth. During those 10 hours, the dark beads stayed remarkably stable in shape, almost like frozen pearls, but they slowly drifted in position over the longer stretch of the observation. Meanwhile, the broken star beneath them held its lopsided shape the entire time, never filling back in to become a full, even 6-pointed pattern. It was as if 2 separate storms, one high up and electric, one lower down and gassy, had each settled into a strange, stubborn shape and simply refused to change. Scientists then noticed something that made the mystery even deeper. Some of the brightest arms of the broken star seemed to line up, at least roughly, with some of the dark beads sitting far above them. That kind of alignment is exactly the sort of clue a detective loves, because it hints that the 2 layers might be physically connected, reaching across hundreds of kilometers of empty space to influence one another. But here is where the story gets honest instead of neat, and honestly, this is the part I find most interesting. The research team looked closely at that alignment and found there was very little evidence that the dark beads were actually being driven by the star pattern underneath them. In other words, the clue that looked so promising did not fully hold up once they checked it carefully. Scientists will tell you they do not fully understand this yet, and that is not a weakness in the research, that is simply where good science stands right now. To make sure they were not fooling themselves, the team systematically tested other possible explanations too. Could the dark beads be caused by Saturn's shimmering auroras, similar to the northern lights we see on Earth, just much bigger and stranger? They checked and ruled that idea out. Could tiny particles falling from Saturn's rings down into the atmosphere be creating these shapes, like invisible rain disturbing the gas below? They checked that too and ruled it out as well. One by one, the obvious answers kept failing the test, which only made the real explanation feel further out of reach. Let's zoom out for a second, because it helps to hold two very different pictures in your mind at the same time. On one hand, you have a spacecraft the size of a tennis court, sitting 1,000,000 miles from Earth, using a mirror coated in real gold to capture light too faint for human eyes. On the other hand, you have something as small and familiar as a jar of glass beads sitting on a kitchen shelf, which is basically what these dark patches looked like once they showed up in the data. Space science often works exactly like this, jumping from the almost unimaginably huge down to something you could hold in your hand. The research behind these images did not happen by accident, and it is worth understanding who actually did the work. The study was carried out using JWST's near-infrared spectrograph, a highly sensitive instrument built to break light apart into its different wavelengths, almost like a very advanced prism. The findings were peer-reviewed and published on August 28, 2025, in a respected scientific journal called Geophysical Research Letters, the kind of publication where new discoveries have to survive intense scrutiny from other scientists before they are allowed to appear in print. Professor Tom Stallard, an astronomer at Northumbria University in the United Kingdom, led this research, working alongside a wider international team supported by funding from groups including NASA's Solar System Workings Program and the European Research Council. JWST itself is a joint project between NASA, the European Space Agency, and the Canadian Space Agency, three of the biggest names in space exploration on the planet, all cooperating to build and fly this single incredible telescope. When a discovery has that much institutional weight behind it, checked and rechecked by professional astronomers before publication, it becomes very hard to dismiss as some kind of fluke. Now, to really appreciate why this matters, we need to talk about the storm sitting just underneath all of this, the one shape on Saturn that people already knew about long before any of these new discoveries. Wrapped around Saturn's north pole is an enormous six-sided storm, shaped almost exactly like a hexagon you might draw in a math class, except this one is roughly 18,000 miles wide enough to fit about 4 planet Earths lined up side by side across it. This hexagon storm was first properly imaged decades ago, and later studied in incredible detail by the Cassini spacecraft during its 13 years orbiting the planet. Scientists believe a fast-moving river of gas, called a jet stream, circles the pole and somehow locks itself into this six-sided shape, although even now, the exact reason for that shape is still not fully settled among researchers. The hexagon rotates in sync with Saturn's interior, completing one full turn roughly every 10 hours and 33 minutes, like clockwork, storm after storm, year after year. Here is where the new discovery gets its emotional punch. That broken four-armed star sitting in the stratosphere appears to hover almost directly above this famous hexagon storm, and scientists suspect the two might be connected, with the star pattern possibly shaped by unknown processes tied to that same swirling hexagon deep below. Imagine standing on a rooftop and noticing that the shadows in the clouds above your city seem to match the shape of the streets below, streets you can barely see. That is roughly the kind of connection scientists are chasing here, a shadow-like link between two layers of gas that should, by most models, have nothing to do with each other. Try to imagine what it might actually feel like if you could somehow float in that upper layer of Saturn's atmosphere. There would be no ground beneath your feet, only a thin haze so faint it would barely register as anything at all, cold and silent, lit by a distant shrunken sun that would look almost like a bright star rather than the warm disk we see from Earth. Far below, the muffled hum of Saturn's magnetic field would twist charged particles into slow, ghostly patterns, invisible to human eyes but painfully clear to an infrared camera 1,000,000 miles away. So here's a question worth sitting with for a moment. If you had to guess, right now, before we go any further, Do you think the dark beads are causing the broken star? Or do you think the broken star is somehow shaping the dark beads above it? If this kind of real, unanswered space mystery is the sort of thing you enjoy chewing on, give this video a like because it genuinely helps the channel know that stories like this one are worth making more of. Let's go back to those numbers for a moment, because as we get deeper into this story, the precision only gets sharper, and sharper numbers tend to reveal just how strange something really is. The dark beads were found specifically between 55 and 65 degrees north latitude, a fairly narrow band when you consider Saturn's entire globe. The ionosphere layer they live in sits almost exactly 1,100 kilometers above the cloud tops, while the broken star in the stratosphere sits about 600 kilometers up, meaning the two features are separated by roughly 500 kilometers of nearly empty space, a gap wider than the distance between many major cities on Earth. To help that sink in, 500 kilometers is a little more than the driving distance between New York City and Boston, except instead of a highway connecting them, there is only thin, freezing, almost weightless gas, and somehow, possibly, an invisible thread of physics reaching across it. Scientists do not yet know exactly what that thread is made of, or whether it truly exists at all, which is precisely why this story is still considered open, unfinished, and very much alive in the research world. It is worth pausing here to notice something else about how strange and unlike anything else these features really are. Every other planet in our solar system with a thick atmosphere, including Jupiter, Uranus, and Neptune, has been observed by powerful telescopes at some point over the past few decades. None of them, not one, has ever shown a beaded chain like this in its upper ionosphere, and none has ever shown a lopsided, broken star glowing in its stratosphere. Whatever is happening above Saturn's North Pole appears, so far, to be completely unique in the entire solar system, a one-of-a-kind fingerprint on a planet we thought we already understood. The third discovery puzzled scientists the most, and it has less to do with a shape and more to do with timing. Saturn does not stay the same all year, and by the way, 1 year on Saturn is not the same as 1 year on Earth at all. Saturn takes about 29.5 Earth years to complete a single trip around the Sun, which means its seasons stretch out far longer than anything we experience here. When JWST captured these images, Saturn happened to be moving through a very particular point in that long, slow, seasonal cycle. Scientists expected that whatever process was creating the beads in the star would likely be tied to something stable and unchanging in Saturn's atmosphere, something that would look roughly the same no matter when you observed it. What they found instead was a system that seemed to be linked to this specific, narrow window of seasonal change, meaning the shapes might shift, weaken, or even vanish entirely as Saturn continues its slow orbit. Compress that thought for a second because it means the picture we now have might be temporary, a snapshot of something that will not look the same again for years, or possibly decades. This is exactly why Professor Stallard and his team have been pushing for follow-up observations using JWST again soon, since neither the ionosphere nor the stratosphere on Saturn can be studied properly from telescopes on Earth. If nobody points a powerful enough instrument at Saturn again during this same seasonal window, some of these details could simply slip away unrecorded, hidden once more behind the same faint, whisper-thin haze that hid them for decades before 2025. This is the part of the story where scientists openly admit the models had predicted something different from what they actually found. Before these observations, computer simulations of Saturn's upper atmosphere generally predicted smoother, more even patterns, without sharp beads or lopsided stars. The real data broke that prediction cleanly. This is still debated among researchers, and there is no single agreed-upon explanation yet for why Saturn behaves this way while every other giant planet in our solar system apparently does not. If a mystery like this, one that professional scientists are still actively arguing about right now, is the kind of story you think more people should hear, share this video with someone you know who loves space, weird science, or things that genuinely don't have an answer yet, because stories like this deserve to travel further than just one person's feed. Passing it along helps this exact kind of careful, honest science reach people who might otherwise never hear about it at all. Let's talk numbers one more time, because by now the story has earned its most precise details. The observations behind this discovery were made using 26 separate dither-combined images, a technique where the telescope takes multiple overlapping pictures and blends them together to cancel out noise and reveal fainter details, almost like taking several slightly different photos of a firefly in the dark and combining them until its glow becomes clear. Those 26 images, stitched together, are what finally let scientists see a layer of Saturn's atmosphere that had stayed essentially invisible for the entire history of space exploration. Compare that kind of patience and precision to something small and familiar. 26 overlapping photographs is roughly the same number of pictures you might take trying to capture one perfect shot of a moving pet, snapping frame after frame until finally, on the 26th try, the blur clears and the image finally holds steady. Except in this case, the moving subject was not a cat or a dog, it was an entire alien atmosphere, 900 million miles away, 373 miles above the swirling clouds of a planet built almost entirely from gas. So let me ask you this before we head into the ending. If scientists somehow prove, a few years from now, that Saturn's broken star really is being shaped by something happening deep inside its famous hexagon storm, would that change the way you think about the rest of the planet's rings and moons? Leave your answer in the comments because it genuinely helps me understand how deep you want future videos on Saturn to go. Step back for a moment and think about what this actually means for how we understand giant planets in general. Jupiter, Uranus, and Neptune all have their own upper atmospheres, their own ionospheres and stratospheres, sitting largely unexamined in this same way Saturn's was until 2025. If Saturn was hiding a completely unique structure this whole time, simply because nobody had the right tool to look closely enough, it raises an honest, slightly uncomfortable question. What else is quietly sitting above the other giant planets in our solar system, waiting for someone to finally build a telescope sharp enough to notice it? There is something almost humbling about that idea. For hundreds of years, people looked up at Saturn with basic telescopes and saw only a beautiful ringed ball hanging in the dark. Even after robotic spacecraft started visiting in the 20th century, our pictures stayed limited, filtered through instruments that simply were not sensitive enough to catch a whisper-thin layer of glowing gas far above the clouds. It took a telescope built with a mirror coated in real gold, parked a million miles from home, patiently blending 26 faint images together just to finally catch Saturn showing its true, strange face. And that face is still not fully explained. The dark beads remain unexplained, the broken star remains unexplained, the possible connection between them remains, at best, only partly supported by the evidence collected so far. Scientists ruled out the obvious explanations, checked the promising leads, and were left holding a genuine, honest mystery, the kind that does not resolve neatly in a single research paper, no matter how many named professors, universities, or space agencies stand behind it. That, in a strange way, is exactly what makes this discovery so exciting rather than disappointing. Space exploration is not really about telescopes handing us finished answers wrapped up with a bow. It is about opening a door just wide enough to glimpse something new, something that raises more questions than it settles, and then spending years, sometimes decades, slowly working out what that glimpse actually meant. Right now, above the frozen North Pole of Saturn, that door has only just cracked open. Think about the sheer range of distance packed into this single story. On one end, you have Saturn itself, sitting roughly 900 million miles from the Sun, so far away that sunlight takes over an hour just to reach it, arriving weak and pale compared to the bright daylight we take for granted here on Earth. On the other end, you have a string of dark beads and a lopsided star, features so small on a cosmic scale that they would fit comfortably within a single close-up photograph, details you could almost trace with your finger on a screen. Big and small, distant and intimate, all wrapped inside the exact same discovery. It is worth remembering, too, that none of this would have been possible without ordinary human patience stacked on top of extraordinary engineering. Somewhere in a control room, a team watched data stream in from a telescope parked farther away than any human has ever traveled, wading through 10 hours of observation, checking image after image, refusing to jump to conclusions until the evidence held up. That kind of quiet, careful persistence rarely makes headlines on its own, but it is the actual engine behind every strange, beautiful discovery like this one. And maybe that is the real lesson hiding underneath the beads in the broken star. Saturn spent centuries being treated as the simple, pretty planet, the one people photographed for its rings and rarely studied for its chaos. It turns out the most complicated, least understood weather in the entire solar system might have been sitting quietly above its North Pole the whole time, waiting patiently for the right kind of eyes to finally look up and notice. So let's go back to where we started, because now the picture looks completely different. We open this video with a strange, broken star hanging above Saturn's pole, missing two of its 6 arms, a shape that sounded almost impossible the first time you heard it described. Back then, it was just a curiosity, a strange fact meant to pull you in. Now you know exactly what it is, where it sits, how far above the clouds it glows, and just how many honest, unanswered questions still surround it. You also know something most people scrolling past a headline never stop to learn. You know that a chain of dark beads drifts quietly above that broken star, separated by roughly 500 kilometers of nearly empty gas. You know a team led by an astronomer in the United Kingdom spent 10 careful hours watching these shapes hold their form, testing explanation after explanation, ruling out the easy answers one at a time, until only the hardest, most honest answer remained. We do not fully know yet. There is something quietly powerful about ending a story there, instead of pretending it is finished. It would be easy for a video like this to promise you a neat, tidy solution, a single sentence that wraps the mystery up and lets you move on with your day. But that would not be true, and the truth here is actually more interesting than a fake ending could ever be. Right now, tonight, this very question is sitting unresolved on a scientist's desk somewhere, waiting for more data, more patience, more careful hours of watching. Once, only a small handful of astronomers pointed their instruments towards Saturn's faint, hidden upper atmosphere, chasing a whisper of light that almost nobody else even knew was there. Now, because of a paper published in August of 2025, and because you just spent several minutes listening closely to how it unfolded, that whisper belongs to you too. Few people know this story exists at all. Fewer still understand what it actually means. But understanding it, even a little, connects you to something genuinely rare. A live, unfinished mystery still being worked out in real time above one of the most familiar planets in our sky. So the next time you see a photograph of Saturn, its rings glowing gold, its surface looking calm and quiet and settled, remember what is actually happening far above those clouds. Remember the dark beads drifting slowly through freezing electric gas. Remember the broken star, missing 2 of its 6 arms, still unexplained, still glowing, still waiting for someone to finally understand it. Saturn was never the quiet planet everyone assumed it was. It was only ever waiting for the right telescope and the right kind of attention to prove otherwise. Carry that with you. The next time somebody tells you a mystery has already been solved, that everything worth discovering has already been found, think of a lopsided star quietly glowing above Saturn's North Pole, and remember that the universe is still, patiently, waiting to surprise us.